Hey, hello. I'm Yoav Luft, and I'm going to talk about the age-long question that I've thought about like about a year ago, of whether the JavaScript community is finally adopting functional programming. And to try and bring you up to speed on how I came to this question, I first had to learn about functional programming, and I done that while working at a company that had a lot of Python servers that needed to handle a lot of requests really fast. And I started to investigate how we can improve that. And I've heard of an awesome language called Erlang that was designed for exactly this use case. I never managed to convince my managers to adopt Erlang, but I had learned about functional programming. And from Erlang, I've moved and actually ended up learning Haskell. And from Haskell, I ended up learning Elm and falling in love in this small, great language. But still, I ended up working mostly with JavaScript. And I was very convinced that functional programming is the way to go because it solved a lot of problems and it seems so clear and easy to understand, and there's much less bugs in the code. But years went on, and I moved to a different company. And again, working mostly with Python and JavaScript, I brought my all my functional foo and declarative jutsu to the company, and they were not happy about it. In fact, they were not even it's not even that they didn't like functional programming. They're not happy about me using declarative programming. And even they had problems when I used object oriented design patterns. And that made me think, well, maybe my assumption that functional programming is the way to go and that's the right thing, maybe it was a bit of a misconception. So eventually I left this company, and but the problem kept on bugging me and thinking, well, what is functional programming really the way to go? And are people really adopting it, or is it just like a small community of functional programmers who write about it a lot and everyone else simply don't care? And with this question, I ended up speaking with a professor of mine from my bachelor degree, one Professor Faitelson from the Hebrew University of Jerusalem, and he studies how people actually use programming languages. And this led, and I was convinced that maybe, yes, that can be an interesting research. Now, I'm not a student at any university, so this is an independent research. And the results you'll see are pretty early, but still, let me give you the short version. By analyzing code from the top 100 JavaScript projects on GitHub and extracting specific patterns from the actual code, I've managed to reach the conclusion that the JavaScript community is adopting declarative programming. Well, okay, I hope you enjoyed that. But really, um, before I start and explaining how come from functional programming I moved to declarative programming and why I've been looking at JavaScript and what were the results, just allow me to introduce myself. So my name is Yoav Luft. I grew up and lived in Israel up until recently, where when I moved with my partner Dafna to Stockholm. And I've been doing web programming mostly, but I've been also developing games. That's a screenshot from a game I developed, and some weird projects like robotics. And beside programming, I try to be involved in the programming community. So in Israel, I founded a conference called Flip, which is inspired by Lambda Days and Lambda World, although that's my first time at any of those conferences. It's the first functional programming conference in Israel, and it's preparing for the next iteration that will be sometime in late summer. And I've also worked on a diversity centered hackathon called HackExtend that was founded by my partner Dafna. And today I work for an agency called Prototyp, where we create crazy and amazing projects for our clients. So just a brief overview of what I'm going to talk about. I'm going to start by explaining why I chose JavaScript to begin with, and next explaining what do I mean by adapting functional programming. Then I explain how I collected the data and how I worked it and created something useful. And finally, I'll give you a short overview of what can be done next. So let's begin. Why even talk about JavaScript? And especially, why should we care about a language such as JavaScript in a functional programming conference? And I think that in order to understand that, we need to understand the history of JavaScript. So JavaScript was created in 1995 by Brendan Eich, who was hired by Netscape to integrate the scheme programming language into the Netscape Navigator. That was the most popular browser at the time. Ike was inspired by Scheme, but also by one of the original object-oriented languages called Self, which was itself inspired by Smalltalk. But sadly, management wanted him to develop a language that is more like Java, because Java was really popular at the time. And they gave him full 10 days to come up with a prototype that ended up being the actual implementation. And this is how we got JavaScript. So JavaScript ended up being a mostly imperative language with a syntax very similar to C. But it also has features such as function as first-class citizens. It's a universally typed language, what's more commonly known as a dynamically typed language. But it supports object-oriented programming in the form of a thing called prototypical inheritance, which is kind of weird if you're coming from Java background. It uses the hash map as its fundamental data type, and it also the data transfer representation called the JSON format, which I guess everyone in this room probably met at some point. And it uses a feature called delegation using the this keyword, a feature notoriously known as being very confusing, especially to people who come from languages such as Java. And this was put beautifully by a Twitter user called Earlbaum. I didn't manage to find his full name, and excuse me for his language. He tweeted, JavaScript makes me want to flip the table and say, fuck this shit. But I can never be sure what this refers to. So JavaScript ended up being an extremely popular programming language because it runs on web browsers and it runs on all web browsers. How popular? If you look at the Stack Overflow survey from 2018, you'll see that programmers rated JavaScript as the most popular programming language, with 69% of respondents claiming knowledge of the language. And it was like that in the last 6 years. In that same survey, the top 3 most popular frameworks are all JavaScript frameworks, with Node.js in the lead, and that's a backend framework, kind of implying that JavaScript is not just it's not just a front-end language, it's also a backend language. And talking about backend, the website Similar Tech that compares technologies rates Node.js as the 3rd most popular backend framework. But one thing that's a bit confusing is that the 4th most popular is Express, which is actually a framework built over Node.js. So together they match with the 2nd most popular one, which is I think ASP. Yes, that's ASP.NET. And on GitHub, JavaScript was the #1 language for new repositories in the last 4 years. So it's extremely popular. And even so, why should we care? I mean, we're not here about being popular. At least I'm not here about popularity. That's not what I care. But fact is that JavaScript can be very accommodating for functional developers. It has features such as anonymous functions and closures, and it uses things such as continuation passing, and also has very nice structured modeling of asynchronous code that was inspired by monads. And in fact, if we look at the work done by the Technical Committee 39, that's an ECMA committee in charge of the JavaScript standard, it seems like they encourage a lot of new features that are inspired by functional programming, including stuff such as anonymous functions shorthand, which is now widely used. But there's also some interesting pending suggestions, such as tail core optimization and partial application syntax and even pattern matching. So it seems that JavaScript might work as a functional programming language, but we still with the question, what does it mean to adopt functional programming? And I think that in order to answer that, we need to, so just Googling JavaScript and functional programming will turn up hundreds, if not thousands, of blog posts about functional programming in JavaScript. But the question is whether are those representative of the general trends in the community, or those are just functional programming eccentrics that really love to write about functional programming and they don't care if people actually use that. In order to answer that, we need to define two parts: what's adapting and what's functional programming. So let me start with the easy part, and that's adapting. After reading a few dictionary definitions, I came up with my own useful definition for this project. And it says that functional programming was not popular and or was not formally accepted in JavaScript in the past. And today it's becoming more popular and more formally accepted. That's an easy one. What about functional programming? Well, when faced with the problem of definitions, I do what every millennial does. I look it up in Wikipedia. And in order to determine how much JavaScript is functional programming, I needed some criteria. And working from the very long definition in Wikipedia, I came up with three nice things that we can use. First is defining functional programming as computation as the evaluation of mathematical functions. It also said that functional programming avoids changing state and mutable data. And it says also that it's a declarative programming paradigm. So let's see if we can turn those things into criteria that we can use in order to determine how much a piece of code is functional programming or not. Starting with computation as the evaluation of mathematical functions. And a mathematical function is a function that takes its arguments and maps these arguments to a single value. And if we want to look at it as a code example, we can see this small function that does appending. It appends the value x to an array and returns a new array. So if we call this function again and again with the same arguments, we'll always get the same result. On the contrary, a non-mathematical function will not return the same result when being called again and again. And in this example, we don't pass the array, and if we call it again and again, we'll get a new result, and that's a different array. What about avoiding change in mutable data? I find this one to be very simple to grasp because it's easy to understand what's changing states and what mutating data is, especially if you've been programming for a while. But the trouble is that all real programs that live in the real world outside of like toy programs need to mutate or change some state. This is usually done because we want to communicate with the user in some way. But the trouble is that it's very difficult to determine whether a piece of code is mutating state or using mutable data because that was the required side effects of the program, or simply because that was a design decision made by the use of a certain algorithm that requires data mutation. There is one small ray of light, and JavaScript had introduced the const keyword for immutable references, and it does have the freeze method that allows you to turn uh, objects into mutable objects. And there's a few libraries that support and encourage the use of immutable data structures. The most famous one is called immutable.js. So we might want to look at those. And finally, we have declarative programming paradigm. And again, I needed the help of Wikipedia. And Wikipedia said that a declarative programming paradigm is, and I'll read out loud, a style of building the structure and elements of computer programs that expresses the logic of a computation without describing its control flow. And it might sound a little bit vague in the beginning, but I noticed just like the last part, without describing its control flow. And JavaScript, coming from a C kind of syntax, has a nice and not very big set of control flow structures. Those include things like while loops, and not one, not two, but three different kinds of for loops. It uses branching, of course, using the if-else statements, and also supports a thing called the trinary expression, and uses switch statements, and it also supports something called labels, which is just like C's go-to statements, but I actually never seen them used in real code. And the question is, if a piece of code is more declarative, then it will abstract away some of those structures, but which one? And branching structures don't seem like the best candidates because the only way to replace if-else statements is with the trinary operator. And this operator is very terse and it's hard to read. So I'm guessing it's not going to be super popular. Switch statements are quite popular in JavaScript because they're being used as a kind of pattern matching. And the trouble is that there's no agreed upon way to replace them. There's like no standard of how to do pattern matching other than using switch statements. So it pretty much leaves us with iteration constructs, while and for loops. But luckily for us, the JavaScript standard does define some very good replacements for them in the form of the map, filter, for each, and reduce functions that should be familiar to anyone who's ever done functional programming. And in fact, combined with some few other functions defined in the standard library, I'm convinced that we can replace every piece of imperative iteration in JavaScript with a declarative version that does the same thing. We can see two small examples. I'm not going to go into the details. Just believe me that the code on the left and the code on the right do exactly the same thing, but the declarative one is shorter and easier to read. Not only that, there's a nice set of libraries that define aliases for those functions and define higher order not exactly higher order functions. They define more specialized versions of those functions, so that can be used for even better way to express complex iteration on data. So this eventually led me to think that probably iterations are the best way to go when trying to determine whether JavaScript is adopting a more declarative programming style. And that ended up being the goal of the research. Which brings me to the quest for data. So this requires some data. And going back to my original meeting with Professor Faitelson, uh, he advised me that I should look for projects that are first open source because I want to look at the actual code. Second, they have a lot of contributors because I want to be able to say something about the JavaScript community, not about a small amount of people in the community. And finally, if I want to say anything about changes and trends, I will be better off if I have projects that have been around for a while. So I end up using the top most popular JavaScript projects on GitHub. And those include names such as AngularJS and 3JS and Vue.js, D3, and the Atom Code Editor, Webpack. Um, I don't remember, like Chart.js. The list is very long. And I needed some process in order to gather data. So this diagram explains the process, and I think it should be quite obvious. No? Okay. So starting from a list of repositories, I'm fetching the metadata for each repository and save it on the side. It will be used later. For each repository, I've selected the last commit from 2009, 2012, 2015, and 2018. And for each commit, I downloaded a snapshot of the repository at the time of this commit. For each JavaScript file in the snapshot, I ran a process that transforms the JavaScript code into its abstract syntax tree, which is kind of easier way to look into the code. Finally, some filtering needed to be done because not all files were possible. And I took the result, those abstract syntax trees, and I passed them into a program that looked for specific patterns in each file. And those were aggregated and created my sample data. Some terminology that I'll use when talking about data. A project is just a repository on GitHub, while a sample is the data on specific patterns used in a repository or an aggregation of repositories. And a sample year, and that's something I'll use a lot, is the sample taken from a specific year that can be a single repository or all the repositories. And the patterns I looked for are iterations, imperative iterations in the form of for loops and while loops, and declarative iterations in the form of for each calls, map, filter, and reduce, and also common analyses used by libraries. And before I'll go into the results, let me introduce the sample. Starting with a list of 100 projects, I started with plotting what projects actually ended up being in the sample for each year. And this graph. It counts the number of projects in each sample in each year. And we can see that in 2009, I had only 3 projects. So most graphs were discarded this year. And in 2018, I had 79 projects. It should be noted that some projects only appeared in one sample. There are projects that appeared in 2012, but not in 2015 or something like that. So might explain some weird stuff in the data. And I wanted projects that have been around for a while, and this graph shows the cumulative distribution of the projects by age. Age is the date the repository was created on GitHub. And we can see that about 50% of the projects were created before 2014, which means that they have been around for more than 5 years. And I think that qualifies as being around for a while. And that brought me to the question of how much data I have. And this graph shows 2 different pieces of data. The blue line is the number of lines of code in each sampled year, and the red line is the number of JavaScript files. And we can see they're using different scales. And we should look mostly on how those lines change. And we can see this from 2012 to 2015, the those projects tripled the amount of lines of code and doubled the amount of files. But from 2015 to 2018, there was a decline in the rate in which the number of lines of code grew, but the number of files kept on growing quite steadily. This might indicate that the projects are refactoring and breaking old code into smaller files. And now that we're familiar with the projects involved, I think we can talk about the actual results. So, as I said, I've counted different patterns in the code. And this graph shows the stacked count of all the different patterns. Starting from the top are the 4 imperative patterns: while loops, for of, for in, and C-style for loops. And below them are the declarative patterns: for each, reduce, map, and filter. The green line separates the declarative and the imperative lines because at some point we'll only care about them. Now we can see that the total number of iteration constructs kind of flatlined between 2015 to 2018, but we know that the amount of code did grow. So I want to see what's the density of iteration constructs, or how many iteration constructs we have per line of code. And this is this graph. And it confirms this intuition that they are declining. The question is whether they're declining because iterations are not that important, or maybe projects are moving to more higher level APIs that I didn't look for. That's something to consider. One important thing in this graph is that you can see that while the density of iteration constructs is declining, the density of the declarative iteration constructs is declining more slowly. So it seems pretty promising, at least from my perspective. This brought me to try to compare the different constructs to each other. And this graph is just, it compares the part of each construct in the sampled year. And from this graph, we can see the obvious trend. The part of declarative iteration constructs is increasing, slowly passing the 40% line, starting at about 37% at 2012, and now they're at about 42 or 43%. Even so, C-style for loops are in the lead, and in 2018 there were still 34% of all iteration constructs. Another interesting thing in this graph is the little yellow line that's reduce. And surprisingly enough, the relative part of reduce haven't changed much over the years. It stayed around 1% of all data. So conclusions so far. It seems that projects are using less iterations, which might be relevant or might be not. And it seems that they're using more declarative iterations. Well, I think that's great. That's really good. But they're not using that much of them. And my initial intuition was that declarative programming is taking a JavaScript community by storm, and turns out it's more like a small drizzle. But I wanted to see if I can understand what kind of projects change. So I've picked up a few projects and I've plotted the change just in each project individually. And we can see in this graph that they take different approaches. The y-axis, and this y-axis, will be used in all of the next graphs. So let's familiarize ourselves with that. It represents the ratio between declarative constructs and the total number of iteration constructs. And we can see that some projects, like the blue line starting at the bottom, started with a very imperative kind of programming style, having a very low ratio, and slowly moving to a more declarative programming style. While some projects The purple line at the top, that's sales. It's a very common web framework for servers. Started declarative and stayed declarative. But some projects are actually moving away from declarative programming, or some projects moved from somewhat declarative to very declarative and then moved away to very imperative. You can see the yellow line. I think that's Webpack. So, feeling that this information is quite useful, I repeated the process for all projects that appeared in more than one sample, and ended up with this graph. Not that useful. But the thick magenta line is the average ratio of all projects. And we can see that on average, projects do move from more imperative iteration to more declarative iteration. And I think that is promising. But I want to understand what kind of projects are adopting declarative programming and what kind of projects are staying in the imperative world. And for that, I took just the declarative ratio from the last sample in which a project appeared and compared it to different attributes of the project. I started out with the age of the project, and this graph shows in the x-axis the age of the project in years, and the y-axis is the same declarative ratio that we've seen before. And we can see that the newer the project is, the younger it is, the more likely it is to use a declarative programming style. And the line in the middle, that's the regression line. So it kind of helps us see that, well, newer projects prefer declarative programming. That's nice. And what about the number of forks? For those who are not familiar with the GitHub workflow, on most projects, in order to contribute code, you first need to create a fork of the project. That's an individual copy of the project. You make your changes on this copy, and then you ask those changes to be merged back into the project. So in a way, I assume that forks are a good indication of the amount of collaboration done on a project. And we can see there's a slight inverse correlation between the amount of declarative iteration code to the number of forks. But it's a very weak correlation, so it might not be that important. Now, I've mentioned earlier that I selected the top 100 projects, and GitHub uses something called stargazers in order to rate projects. So if you go to a repository on GitHub, you'll have a small star icon, and if you click on it, it wouldn't change anything for you, but it will increase the amount of stargazers for a repository. And we can see that this popularity index, the number of stargazers, does not seem to correlate at all with whether the project prefers declarative or imperative style of programming. And finally, I've looked at the number of individual contributors for a project. This data was gathered manually because you can't do it using the GitHub API. So I had to go to the homepage of each project and write down the number. Well, I actually wrote a script that does that. And we can see that there is a slight correlation between the number of contributors and the declarative ratio. And while it's not a very obvious kind of relation, it might indicate that either the majority of programmers prefer declarative programming, or that projects that use declarative programming attract more programmers. That's definitely something worth investigating. So what were my conclusions from that? It seems that the most obvious one is that newer repositories and newer projects prefer declarative programming, which supports my intuition, my original hypothesis, that the community as a whole is moving to more declarative iteration style. But it's not that conclusive, and I think further work can be done on that. And just one final thing. Earlier, I mentioned that there are some libraries that help programmers use a more declarative programming style, and some of them actually encourage a very functional programming style, such as a library called Lambda that was inspired by, I think it was inspired by Haskell. They use Haskell-like type signatures. So I've took a small peep into the dependencies of the different projects, and I've tried to gather how many projects use those libraries as their dependencies. And that's a stacked count. And the red part are projects that do not use those libraries, and the blue part are projects that do use them. And while we can see that there is an increase, more projects are using them, it's still less than quarter of the projects. So it appears those libraries are not super popular. I'm not sure if they're an indication. As I said, this research is an independent research, and there's still things to do next. But let me start with you. If you have to write code that run on web browsers, but you really don't like JavaScript, there are some good alternatives that you should consider. I've mentioned my liking to the Elm programming language. I think that's a language that solves many of the problems of web programming, and it's a small and fun and a super. I can't recommend it enough. If you're coming from a Lisp background, you might want to look at ClojureScript. That's a Lisp inspired language. Or if you're coming from Haskell, you might want to look at PureScript that was inspired by Haskell. And it's very similar, but kind of more oriented for running on web browsers. Another language that took a familiar language and turned it into a version that is more appropriate for web browsers is Reason. And Reason is quite trending today. It was inspired by OCaml, but it has very good interoperability with JavaScript. And you can also wait until the WebAssembly standard will mature and then just compile your code to run on any web browser. But this might take a while. Oh, sorry, Mr. Logo. And as for me, I still have some work to do on this research. There are some things that I should look at. For example, it might be worthwhile to look at a larger sample. Maybe 100 projects are not a good enough indication for the general trend. And maybe I can examine other kind of patterns, how assignments are being used or how branching is being used. Another option is trying to look at higher order functions. Higher order functions are a strong trait of functional programming, and they are being used in JavaScript, so they can be a good indication if they're easy to find. I might consider looking at specific examples in more detail. Specifically, I'm thinking about trying to show if we can convert pieces of imperative code to declarative code and how complex it is. Or I might want to look at the data at a smaller time resolution, maybe sampling each year, each month, or maybe even each commit. And finally, we can look at whether projects are actually moving away from JavaScript to programming languages that are more accommodating for functional programming. So that was basically it. As I said, that's an independent project, a research that I keep on doing. And if you'd like to discuss that with me, feel free to hit me up on Twitter or write me an email. And if you want to discuss fun projects that use functional programming or not necessarily functional programming, that's the kind of thing I do in Prototyp. So also feel free to contact me. And I hope you enjoyed. If you have questions, I would rather to take them offline and not do that on stage, although I think we do have a little bit of time, but that's it. Thank you.
So we do have quite some time for questions. Anyone? Okay.
There were some plots on your slides, and there was a spread data, and you are making there a regression line. But what I've got some doubts about if it's right to make a regression line if your data is spread all over the plot.
So in terms of what's next, basically what you shown is what still can be done. Yes, but what is it that you're trying to accomplish overall? What's the objective?
So there's several things. First, I was simply curious on whether there's an actual trend or just the apparent of a trend. And that's a thing that we hear a lot in the programming community, especially if you're doing front-end programming. The JavaScript or front-end web development community is really susceptible for things being trendy. So some technology becomes trendy and and everyone used that, and the next year no one used it at all. And functional programming is a very old and mature kind of approach to programming, and the fact that there's a lot of people writing about it in JavaScript doesn't mean that it actually is a trend. I mean, the first code I've seen that called itself functional programming was terrible piece of imperative code. So I thought that a more structured approach to that, like a more data-driven approach, should be taken. And there's not a lot of academic research that does this kind of thing, that look at what people actually use. Most of academic research is concerned about what can be done or different novel ways to implement code. And I want to see what do people actually prefer, what they use. Um, so this research is mostly about that, trying to determine what's actually being used. Um, I do intend to keep on working on that and using help from people in academia and probably massaging this research into something that can be published as an academic paper. But that's I still have a long way ahead of me for that. And I think as a community, well, as I said, it really it's really a community that's susceptible to trends, and I think that we'll see a trend of people moving to more functional programming. Maybe ReasonML is one such thing, and will probably be a backlash. So we'll have to see. Thank you.